So the first thing is, so the sites you know it well. I did some reorganizing yesterday. If you go back to source, and then as always you do browse. I simplify things a bit, so it's under trunk and you have support. And support is basically things that you will need. You have the presentation that I gave on the first day. Yeah, I gave another presentation yesterday, yes. There's more, and then the other thing that we were running is with Track It. And if you just drill a little bit further, you get the other presentation that I gave, just a bunch of more materials. So support is where you want to find things to be. If you get interested in the things that I was telling about yesterday, doing the threshold method yourself, I actually I put the same set of files I've been using called mooring, and you find a script there that has some really interesting outcome on it. We're not going to run through it, but if you feel like poking into some of the deeper issues, seeing what I'm trying to work at, you can go back to this set of files. But yeah, if you have something interesting that we want to publish a paper together, let me know too. Like there are quite a bit of data here. These are all mooring data sets, and there's some free bird data sets in some packages. So I'm just playing with birds data now, trying to. Yeah, they somehow put a lot of text, but then they didn't even bother to filter their positions. I guess they're not fish. So I think it's only fish people or shark people want to filter their positions. Otherwise, it's like, the bird flew somewhere and they're happy about it. Or they better still, they have just better geolocation stuff. They have GSM and GPS. They don't need like geolocation anyways. So that's the setup. So if you want to play around with stuff, it's all in here.
And it's going to be there for a while, or you?
Oh yeah, this one will be there. This one will be there. Like I took off the data sets, so that's why there's no more data. So the data sits within you. If you didn't download it, you miss out. So sorry. If not, just ask Enrico for stuff. But I probably still have it in my computer, but I forgot where I put it now. But support will always be there. I cleaned it out such that it's not exclusive. So I'll just tell you one last function in analyze pset that it will be fun. So now you struggle through putting a track together. Why not just at least have a quick way to look at it? So we were doing a lot of plot map stuff, plot place map. We even modify the fit map script that actually is still on there. If you go to track it, oh my bad, support track it. And we still have the fit map tube script there that allows you to do your own lat long. So those are our stuff. And what if you want a quick way to do a fancy track and show to impress your boss, per se? And you can look for the help from tracks.kml. So that's what you want to. Let me just make my screen a bit bigger. Yes, so tracks.kml is what you want. What that does, it will dump your track into a Google Earth file, a KML, but you can add satellite imagery products to it. So the list of what you can add is endless. Basically, it's using a service from NOAA that allows us to download the imagery. Get blended SST, the other function that we use, operates somewhat similar. Like I basically built that first, and then I took a lot of the code to build this one. So you have the same example. So it's not like you'll be lost doing this thing. Let me just reload this page. Maybe.
What library is it?
Analyze pset. So remember when we do the bathymetric correction, we load analyze pset. So it's hiding within that package. So
But you have to reload it on the line.
you just have to load the libraries.
Yeah, load the library, right?
Yeah, load the library, and then you have that function with you. And I'll just walk you quickly how you call it. We'll look at an example. You can go. The minimal is really easy. So we can get the same fit, the same exercise that we've been doing all along. You have here. Let's see. Yeah. So here you have. You run the fit, and the way to call it, you just do tracks fit, and that should dump it into, I think it should be the working directory. If not, you can specify a folder, like what we have been doing, to dump the file. And that will just give you a KML, and then you can do multiple tracks. So you say you do a few things, and it can supply things as a list. So the only slight complication here, you see, I supply my first argument in characters, in quotes. So that allows you to supply a list of names. So if that way, it's an easy way to give like 5 tracks together to output into the same KML. So you can have 5 sharks or 5 fish going into it, and you can just have a list doing like that. If you do say I want to see all 5 fit together, then you do this. So you can combine fit 1, fit 2, fit 3, and then you close the 2. So you now turn all, this is a character string that you all merge into one factor, and if you do that, you can output all those 3 together. It's explained more in the help, but that's what it does. So I run 2 more fits using the same data sets here. So I have fit 2, and fit 3, and there's a trick in OWL that basically lets me to find anything that call fit. I'll merge them into a factor like this one, but essentially that will do the same thing. It's just a good trick to have. Look for anything that is fit, and then merge them together into a character factor, and I just apply it as an input to the function. So I'm outputting all the fits objects that I've done. Then the other things is now you can add different satellite products. It's specified here. These are product names that you can get from the website, from this website, this guy. So you just have to go to that website, look up any specific product other than the default that I have in there, specify how often you want to get that product, and you can just get all those together. And I'll just show you the website quickly, what that is. It's basically very useful in general for any satellite stuff. It's one of the few things NOAA did really such a good job that I think is not too appreciated about. So if you go on that link, that thing is called AirDAP. It's an environmental science data. Oopsie. Here. And we usually use the gridded data set. So gridded data means it's all in a regular grid, and that's what you want to use. And you see, there's just a whole list of different satellite products from environmental models, wind, phytoplankton, currents, whatever you can think of is all there. So what you have been struggling to download the bathymetry from get bath data is actually trying to go to this site and download it. So a lot of things are driven by this site when we're trying to just get the data. So you essentially can click on anything, say, I want to look at this new Amherst E model output. This is SST, if I remember. So you go to data, and you can do graphs too. You can make graphs right there on the fly. And if you click on data, you can request the data and start downloading. And it will give you the product name. So you can get the ID. And if you get the ID from here, you can use it in the same argument that I was showing you below. So that's the same ID that I'm getting. Get a product, and I do have a few built-in stuff ready. So this is one of the SST data set, and this is one of the chlorophyll data set. So common stuff. So the end result is you can generate a KML with the right imagery and everything in your working directory. But what I usually do, I'll just create a KMC. So KMC is essentially a zipped up folder of all those files. So there's nothing magical. It's just use WinZip or anything, zip it up. Instead of having a bunch of files, you have just one file. You can do it for anything. It's not a special trick. If you don't, you just leave those files, and if you have those files hanging, you double click on it, it will just open up in Google Earth. So the result is you have something like this. Do I have my dots? I don't see my dots too well. It's not projecting. Well, you have to, okay, you see it, you see the track now. Let's see, let me see if I can do full screen. Okay, so I'm zooming a bit. So this is that super long big eye tuner that I have to zoom in order to see the points. Yeah, so you can see how, yeah, that's generated exactly from that, that file, from that track to KML. And you have sea surface temperature lying behind, and then you have your track moving around with the points and the imagery updating accordingly. So it's just a handy option, and you can do a bit more exploring yourself, and yeah, it's just fun staring at it. Use it as screensaver.
Tim, sorry, how did you launch this?
Oh, so okay, I'll just escape here.
So you were on the AirDAP website.
At that website, just provide an argument of any special products you want to get. So essentially, it's already and we have by default. You see, like the input argument here, default will load some SST images. So if I want to go beyond SST image, so as if, okay, I just want to look at chlorophyll instead of SST, then I have to change this argument.
Okay.
So, and in order to know the product name, you have to go to the website. Otherwise, just use some examples that I have here. The other one is chlorophyll, TMBCHLA is chlorophyll A. So, or TMHCHLA. So, that's chlorophyll. You can have multiple layers of those things, multiple tracks, and it'll give you a file. You can open it in Google Earth pretty quickly, and yeah, so that's what is fun. It's perfect for meetings or for your boss and everyone who likes Google Earth. And the file looks like this. So I zip it up, but if you don't do that, let me just close it for now. Just keep running. But essentially, what it is just a zip file. And it's just a bunch of, so what the function will generate is this set of files. You have a KML, some icons for your track, and then just the set of image that it was loading from, that we download from the set of image. So it automates that process for you. You can do that zipping into a file and then just rename the extension to KMC. And then you can pass this file around for any one of your friends who you want to showcase this track to. And that's why I open. Yeah. So that's it. That's the hidden function in our analyze pset that's pretty fancy. Not really published like promoting it because it's kind of in-house, but it's useful for, I guess, visualization. So that was that. Again, to call it, you just have to go analyze pset and do tracks.kml, and you can find the same description. I think that should take care of things. Any question on the geolocation side and stuff? Or any confusions yet to answer through the few days? If not, just let me know when you come across anything. You can find my email is probably you can find it in any of the home pages. It should be below. If you're lazy, just type tagtuna@gmail.com. You'll be able to find me too. Okay, so the other site that I was going to tell you about is Tagbase, and it has the same, almost similar architecture. So you will find yourself very familiar since we've been working on similar setup here. So all you need to do is change the last extension from geolocation to Tagbase, and they'll open up a page there. And I'll just walk through you the quick presentation. So that so Tagbase. So on Google Chrome, this thing doesn't load correctly. So that's why I said I asked you to try just modify what the link that we've been using so far and change it to Tagbase. But on any other browser, I think this would open up correctly. Tagbase.org is just a pointer page to the same project page that we have. It's one of my old colleague who was the postdoc in my lab back in the University of Southern California. He was the one who was helping. He has moved on to NASA. So that's this talk when we put it together was a few years back. But we've been doing this since like about 2006 when we first started handling big data sets for Michael Domeyer. I use that the majority of times I use it is for my Stripe Marlin data set. There's like over 240 tags in it. And they comes in a whole variety of different flavors. It has a few recovered tags that almost half is microwave telemetry, half is wildlife computer. They're all very different, and we're struggling. It's like, how do you do with all these data sets? And they all look so different. And that's the reason we built the database. And just like what I've been saying, it's really lacking attention. These years is getting better because the manufacturer from wildlife computers per se, they're trying to at least have more support in terms of the software, but it's still very piecemeal. They do the Eagle Pro, but Eagle Pro is more like a MATLAB setup. It's not really set up to manage any data. It doesn't do any quality control. It doesn't do any basic stuff easily. It's for writing code. It's like using OWL to manage your data, which is not ideal. It's good for visualization, good for analysis, but not really designed to handle different data sets. And plus, they are manufacturer specific. If you're using wildlife computer software, you can only work on wildlife computer text. You can't really ask it to support microwave telemetry text. There's just no such way. So it's really hard to find funding and support. It's not really a line item on your project. You get your data back, but you're stuck with it. You can't really easily ask someone to handle your data, except when you have really IT support in your group that handles that. And when you have IT support people, they don't really understand what you're trying to do anyway. So that's that mismatch between, like, even if you have the technical help, they may not have the same background as you or asking the same questions as you do. And then we managed to squeeze by. By that, we're really good at Excel. I think that's kind of the trade. The two of the trade. People really like Excel, and I have seen really sophisticated Excel moves, which I'm impressed as well. But that's not a way to handle data. And yeah, and over the manufacturers, it takes time and effort. But at the end of the day, it's a commitment. If you start having the habit early, it's useful and will make a long-term difference. Because what if you need to pass on all your data at some point to someone else? Then they might not have the same understanding of data. If you have a standard format and you clean it up in a way that you can document along the way, then they have a good set to work with. So think about long-term maintenance of your data, and that's the idea behind having tag data management. So this will be, I'll just go through this quickly. Basically, what we are trying to do is, these are this kind of the situation we always have. The people, we're always a small lab group. Like we might have at most 10 people in the group, so we don't really have that much resources. And our strategy usually is like you do it yourself, and there's definitely some software requirements that needs to be taken care of. And hopefully you already have established standards and you already have protocols of how to handle your data, and also workflow in handling analysis. So if the geolocation stuff has become a workflow of you, that's perfect. Then a database should handle this type of your needs as well. And at the end, it's like if you get all these lined up, you can at least able to share that with colleagues or for the future generation of your research program, and all these combine to be a long-term survival of your data. And so these are the components that just on the logistical side of the data once they come back. And the motivation of Tagbase, this is the core. So it's at least it's a centralized database to handle most of the tag data coming from different manufacturers, and they're mostly pet tag and archival tag related. So I still don't know enough about splash tags or bird tags. So they're easier data to handle, but to start off is really fish related to fish and marine animals essentially. This part is not has. At least we should handle some of the metadata in Tagbase. What I'm going to talk on Monday after the keynote is a bit on these sides. So that's why I said it's a non-talk. I'm not really tagging anything. I was tagging tags at that point. So that's will be handled mostly on Monday. So that's Tagbase. There's a nickname, but essentially still Tagbase has components of those, but I decided to build another one that can talk to the two together eventually, and that will handle a bit more on the hardware. But the idea is to have all these protocols, metadata to come into the database, so you don't have to struggle from where do I deploy this tag? Like if one of the computers doesn't know where to deploy the tag, you can't fill in that dialog, and you have 0 and 99, and it drives me nuts. And that's why having a database, at least things can stick together that way. And then at the end, there's a downstream analysis. From the database, you can get those data out. So with OWL, you actually can do an Odbc call, which we didn't do, but it's very simple. You just have to make that connection, and then you can call directly the data out from OWL. And the reason for doing that is I can prepare a specific formatting in the database, because it's already almost like Excel, but you can just say, I want this column, this column, this column, and then once you are in OWL, you can call back the view that you already created without having to output the data. So you connect directly to the database and get it and run your analysis. And the same way, once you finish getting your tracks done, you can basically push it back to the database. So everything now sits in one place. Instead, you have your raw files, you have your analyzed files with the tracks, and they don't really talk to each other, and that's annoying as well. So that's the reason of having a centralized database. And the other goodies that comes within the database, there are some quick reports. It allows you to look at the data quickly. You want to see whether this fish has died, and once you finish the import, you can just bring out a form and look at it. And that is just an easy way for a lot of people to interrogate the data quickly without knowing how to code or even using another software. And this is kind of the distinction in terms of what's out there. There are some simple ones to sophisticated ones. If you are more like a sea turtle person, there's this tool called stats or seaturtle.org that handles it. It takes care of some of the data sets. Mainly it's Argos and GPS stuff, and it can download from Argos for you and do some mapping, but it doesn't really know how to handle acoustic, archival, and pop-up, things like that. So it's not really ideal for fish. You basically need to keep it a track in order to do that, but it's great for sea turtles. It's one of the most popular sites for sea turtle work. Cyro is the giants in the room. It can handle everything, but it's only open to collaborators. And they don't give your data back usually. They will, big organizations, they like sucking in the data, but it's really hard to get them to tell you, how do I get to my data? Then I'll give you all my data, then what? They're really good at long-term preserving, but it's a lot of times one-way traffic. It's hard to get out and say, you want to do analysis here, how do I talk to a giant server somewhere and give you that communication channel? And they may question your firewall is not strong enough and things like that. And that unless you're working directly with them, it's harder for any small group to do that. But they have a good system, so that's Cyro. So and then Tagbase. Well, I'm not doing it right now. It's acoustic tag, but most of the tag that I've come across from the ocean setting is handled, and Argos fetching can be done with Tagbase, which I will talk on Monday, and it's not that difficult to implement yourself. It's basically using a lot of the free software that's available since the 90s, essentially. So I'm kind of in the middle of the road, which you can handle, and the website basically will allow you to help set it up yourself. And there's a bit of learning curve in terms of just knowing how things are, but it will be the same for any systems. Okay, supported formats. It has improved quite a bit now, but it's still the same setup. So it will support low-tech, microwave telemetry, and Wi-Fi computers, and also Desert Star one, because I finally get my hands on some Desert Star results last year or so, or a year before last. And so it's just a bunch of different formats that it will support. And since we have been doing it since 2006 or 7, historic data formats that is already outdated are still supported. So even PAT2 or whatever is supported now. And yeah, so the same table is on the website. It has the most updated information. And this is the import process. It's there. But just going a bit nerdy. Driving behind is a set of, we call it tables, but essentially it's almost spreadsheets, but spreadsheets that are interrelated. So this is called the data model, and essentially it will handle different tag types. So this one is for spot data. There's mostly pet tags and archival tags. Essentially different sets of tables. Data linked up by relationship, so at the end it will relate back to the tag and will relate back to the fish that you have tagged. So all those information will be linked up together, and when you have a system like that, you can use a query to pass through some information to dig out the right information. Say, I tagged a fish a certain day, can you bring out certain data sets from it? So that's allow how I can get to my data quickly. And it's actually, I spent quite some time to build a mapping farm within the Access database. So you can actually bring, once you have your tracks, like what we did, we can incorporate the tracks back to the database itself and load it up on a map. And actually using the same web service I show you to grab the images from the web for satellite oceanography stuff, you can just overlay on top of your tracks. And these are dynamic stuff. So the fun part of having it in the database is any point on the track, if it comes from, it has a track and the data you already imported, if you click on the point, it will bring up the data, so you can actually dynamically link to your data. So, okay, at this point in time, there's a what is the fish doing? Then you can click it up and it will bring up the data set for you on a separate window. So that way I can dynamically look and query my data. And it was really time consuming to get this running as a standalone thing in the database, but it is very useful for quick looks because it's hard to really scroll in even any software and look up the images from the web and have them linked up together. But that interface at least gives you some handover. And then there's also outputs. So you can, once it's in a database, you can really output things for downstream processing. And one popular software is free, it's mostly used for oceanographic data, it's called Ocean Data View. So through the database Tagbase, you can export your data into Ocean Data View. And this pretty stuff is from a recovered text, so that's why you have this high density of data. There's some standard templates that I already created. So the data file is a generic one. ODB will understand it, but how you set up these plots, it takes some time, but there's also a template that I set up for recovered text. So you can do temperature depth 1 through time, and you can do these like daily plots. And I don't know if you're familiar with this, guys. If you look at lights, essentially the higher value is bright, so this is basically day and this is night. And you can even see the moon here, like this strips of the moon. So it's a bit like, some of the plots are a bit like the low-tech LED studio, because I think the Blocks group asked low-tech to build that software they never built as part of the top program. And low-tech's charging for it, so I don't really know how that works out. Plus, like Top's supposed to provide that software for free for anybody, but they didn't do that as well. But they call these Van Gogh plots. I don't know why they call it Van Gogh. But essentially, it's just a daily plot of those. It's easy to do. You can do it even now with Eagle Pro, I think. Well, they're trying to do that, but you can use ODB to do a lot of fancy stuff, and it's actually fun. If you have archival data sets yourself, you should spend some time to play with ODB because it's a very hands-on thing. It's better than Excel for sure, and it handles the graphics very nicely. You can do smoothing in between. You can do contours. If you have done anything with World Ocean Agnes, if you go to NODC sites, you can download ODB files from NODC sites, and you can see the whole World Ocean Agnes in that sense, in similar plots. So for oxygen, salinity, or nutrients data, if you do your transects or oceanographic work, like the TS diagrams, all those can be handled by ODB. So that's just one of the ways that Tagbase are able to support things like this. If you figure out what you want to do, set up a template and output your data in that way. Which I need some money to do, otherwise I still be nowhere. But essentially, that's the website that you're already seeing. Most of the instructions are there. You can come across any problems, let me know. And yeah, that's Tagbase. Okay, pretend that the starting point looks something like this. You do have a bunch of data sets. You can see I have the one computer set up. They've spilled you in like at least 10 or dozen CSV files that actually belong to the same tag or the same group of tags. So I have this one group, then I have another file here, then I have another group here, and I got some other files. So all these, I want to at least bring them into the database. And then there's a process that you kind of do, tell the database what you're trying to do. I am bringing this set, essentially I'm saying that I'm bringing this set of files. This set of files contain all these different fish or individual tags. and it comes in a variety of formats. And so you have to just kind of tell the database, these are the things I'm trying to import. There are some columns that is not absolutely necessary, but if I know exactly my start and endpoint positions and I want to use that instead of what the program can look up, then you should put it there. Then this is just a bit more details for any pad text that has histograms in it. So once you have this file, then you can start the import. So I'm not going to save it now. I'll just open up the database. So right now I'm using a really old database program, Access. This is 2000, but any new ones will work just the same. It just looks slightly different due to updating of the icons. No one uses these small update icons anymore, but everything works the same way. So it'll pop up with a navigation menu. You can do an import, and then you just have to select from the format menu, say go, and if you read the instructions, that will probably guide you through it, not just click around and get you going. And don't worry about this one, just opening a restricted directory. So you browse to that job file that I call. Basically, it's saying, telling me what I'm trying to import. So you can open any one of the job files that I already set up previously, but I'll just go to my simulated data, so the same job file. So again, it's just telling me what things I'm going to import will be exposed in this interface, and then you just click on the fish to import the files, and then you'll just go to your source file and bring it into the database, and it's all done already. So import the full text. So I know I have an archival tag that I imported. So let's look at an archival tag. So you just go back from the interface. Essentially, they're all dumped into data tables back behind the scenes. So these are the sets of tables that host the data. And what I'm showing right now is just some prepackaged views so that I can look at my data quickly. So I can go to plot, and then I can do plot archival data. The problem will load. I don't know why it may show up funny on this computer screen, but it's working. So you go through the cooldown that allows you to select the data. This is an Albert Call tuna. It's in the ocean. And then it's the year of 2008, so I have it. So it just load, and it'll just show, say, these are the dates. I'll need to plot, and then you just click plot, and then it'll just show up as a series. And then you can scroll through, you get a bit of standard plots for everything, and you have these data sets. So that's one way to quickly get to your data. There are plenty of other forms that you can use to play with. You can do an export. So you can export it into certain ways. I do not. Okay, so I can select a particular tag that I import, and I want to export it into, say, KMSSST. I just need to specify where I want to dump the file. You click on fish, and then it will export the tag. And you go to Tagbase, and it already give you the file that I want with the right format, and I can open this R script that it wrote as well. It will give you the right file name already. You just have to run through these lines, and you're well on your way to run your analysis. And once I finish running an analysis, I can bring it back in and just use all the other goodies on the database. But that's the general setup that we have with Tagbase. I think that should give you a good preview. would definitely recommend if you have more than one text at some point, start looking into such options. It's just will make your analysis a lot easier once you have it in the database. That's all. And otherwise, stick to Excel and good luck with Excel programming. Yes.
That file that you used to format the at the beginning has to be in the same folder with all the data, right?
Yeah, or you can just give it the direct path, so it can be sitting with your tag files. So
Yeah, it has to be in the same folder of the tag files.
yeah, or you can just give it the complete path. So if you do C:// wherever that, then your job file can sit anywhere. So I'll just show. I'll point out to you that. Okay, here. So now you see, these are my data files in different folders, right? So these are all like different tag files, and my job file can be sitting in a one level up, but I just have to tell you which folder.
That one. Okay.
Yeah. So if I move my job file away from this directory, I just need to provide how these files relative to my job file.
And the job file comes, the format of the job file comes with the Tagbase?
Yeah, the Tagbase, there's a template, an Excel template in templates. So once you do the install, it will give you the same directory structures. So it's in templates, and there's a job file template. So you start out the template, you can start filling in the information. If not, you can always modify from an existing file that you have already prepared. Just do the same, copy the file, say, in a fresh install after you set everything up, it should have the simulated folder like what I have here. And it already has a job file. And you can just fill it in, just copy this one and modify it essentially. You can, that's just Excel. So you're not, you just need to give it the right information. You can fill in any details you want. Like the minimal that you need will be the yellow. So yellow is the minimal you will need for any text. Depending on tag type, if you have a archival tags are really no lat long usually to go with it, then you have to tell the lat long, which is the blue parts. But if it's more like a pop-up text, most of the stuff are already in that set of files somewhere hiding. So I did spend the time to know where those things are hiding and do it for you. But if you know exactly where you want it, just fill those in. If not, fill in the yellow. And the web page will tell you exactly what you need to do in terms of what you can fill it in here. So if you go back to Tagbase, and then you go to Wiki, and then you have to, the first page you want to do is probably start using Tagbase with our starter kit. There's just all the steps that you want to, you need to do. So the first setup is to get you install the things correctly here. And then from step 5 onwards, it's just what I was trying to show you how you can set up the job file to let Tagbase know what you're importing. And here is just step 7 and 8, you're just starting the database and using the form to do it, which I show you on screen. Step 9 was the import itself. And step 10 is just using it right away or start a query. So a query is like what Google does for you, but essentially you can do the same thing. You set up, you ask the database to show you something using some standard methods. And you can do export data and import the data from geolocation stuff back into the Tagbase and do some fancy export again. And that's the ODP part, and that's it. So this page will guide you through the setup and the first look at it. And there are other dedicated topics on the left-hand side that will explain each of the steps more clearly, or other stuff that you might get to do. So like the integrator mapping part is in one of the page, and you can see how exactly you can use the functionalities given by each of the maps, and it will explain a lot better on those pages. And even though it will take you some time to get to know how to use it, these things are free, and is set up with a mindset of a biologist, because we're dealing with biologists. We are not computer scientists. We're just using the tools to help us to do our job better, but not really get too hung down by the implementation of computer code. So that's Tagbase. Ideally, I would definitely love to help you out to set it up and running, but you probably can try on your own, and it's not too difficult to help you support it over the web or anything later on. So we don't need to spend the time to do that right now. But I definitely highly recommend you to use it or any other things similar. But do try to start the process early, especially if you have more than 5 tags, right? I would suggest that's the threshold. If you have more than 5 tags, start looking into database options. Yeah, so that's my main message.